In this lecture, we are going to take a look at problem 6, a coin tossing problem. And this is an exercise from this book titled See How to Program Neat Edition. So the question says coin tossing, write a program that simulates coin tossing. For each toss, display heads or tails. Let the program toss the coin 100 times and count the number of heads and tails. Display the result. The program should call a function flip that takes no argument and returns 0 for tails and 1 for head. If the program realistically simulates the coin tossing, then each side of the coin should appear approximately half the time for a total of approximately 50 heads and 50 tails. Alright, so we are going to make use of our knowledge of C programming that we have learned so far to tackle this particular problem number 6. Alright, so I've already created a file. I've named it cointossing.c. Alright, so let me close these files. We don't need them. Alright, so here we are. Now it says we are to let the program toss the coin 100 times. Okay, so the program should call a function flip. So we are going to create a function flip that takes no argument and returns 0 for tails and 1 for head. So that means we need arguments. So let's define a function prototype. So we have hash include std our preprocessor directives. So immediately after the preprocessor directives, we can have our function prototype. So we have they say the program should call a function flip that takes no argument and return 0 for tails and 1 for head. So this particular function flip is going to return 0 for tails and 1 for head. So and 0, we know that 0 and 1 are integers, so I can have the return type as int. I can have it as the name of the function flip according to the exercise. It says that the function takes no argument, so we can specify void as the parameter, meaning that void means that it doesn't it doesn't require any argument. When we call the function, we are not going to pass any argument to the function. All right, here we are. So now we move into function main to see how we can continue our coding. It said the program should toss coin 100 times. So that means we are going to call this function flip 100 times. So to call this function flip 100 times from our function main, we can make use of our iteration control structure. Let's make use of for loop to iterate 100 times and call this function flip. So I can say I can define the initial condition int x equals to 1. Then we have the condition if x should be less than or equal to 100, since we are iterating 100 times, and then a step of 1, since we want to iterate from 1 to 100. So I can just have x plus decrement operator. Okay, so next, now all right, so and then for each function, for each iteration, we are going to invoke function flip. So we are going to invoke function flip. I think this is too much, the indentation. All right, so I'm going to invoke function flip. I can invoke function flip. But now let's go and define this function flip and see how this function flip is going to work. So I can have here and define my function flip int flip. I'm going to say that according to the function prototype void, it doesn't require any argument. And when we invoke this function flip, we want it to toss a coin to simulate a coin tossing. And we know that a coin tossing is either a head or a tail. And according to the question, it said that we should use 0 to represent that takes no argument, return 0 for tails and 1 for heads. Okay, so that means that we need a random number generation function. So there I can make use of what you call a function rand. And function rand is a function from this particular header file. So I need to include this standard stdlib header file that include this function rand that is needed to generate random numbers. So I can add my function, my header file that has this particular function. So stdlib.h. So contains for function rand. Function rand. Okay, so now I can now go down and I can make use of rand to generate random numbers for me. So rand, and then I can now the random number can generate any random number, any integer, whole number, random number, any random number, any random number actually. Okay, so but we are not interested in any random number, we are just interested in numbers 0 and 1. So for us to have this 0 and 1, then after a random number has generated the random number, we can divide it by 2 and then get the remainder, because when we divide any number by 2 and get the remainder, we are very sure, we are certain that the numbers we are going to get is just 0 and 1. Those numbers that are any number modulo 2 has to be less than 2, and the numbers that are less than 2 whole numbers that are less than 2 are just 0 and 1. So I can just say rand modulo 2, so that the numbers that I'm going to have in this particular 0 and 1. So I can just return this to my function main. So let me put this within a parenthesis, a redundant parenthesis, and just say return this particular expression. Okay, and also I can seed my random number generation, what we call seeding the random number generating function to what you call to provide a seed, make it so that to make it the random number generate what you call pseudo random numbers. They are not actually random numbers per se, but they look to some extent like random numbers. And to further facilitate the randomness, we can make use of the time at the current time to serve as a seed for the random number generation. So the number generated at this particular time will not be the same number that is generated at in the next seconds, because we know that time is changing by seconds. So if a number has been generated now, in the next 1 to 2, 3 seconds, using time as seed is going to be very much different. We are certain that we are facilitating the random number generated by using the current time as a seed to generate this particular random numbers. So you can Google on this particular random number generating function in C, and then see and get to know more about this particular function rand. Okay, so now I need to, and for me to make use of time to serve as a seed for facilitating the random number generation, that I need to include the header file. So I can just include it as hash include time.h to use current time as seed, to use current time as seed for random number generation, random number generation. All right, so I can just come here and I'm going to perform that seeding before even the function flip is called. So I can here in my function main, I can say srand. It's going to be I'm going to have a time function time, and then I'm going to pass null. So I'm using time function. I'm using time function, which is from time.h to generate the current time, and then I'm passing that whatsoever the current time that has been generated, I'm passing it to function srand, which is a way of providing seed to the function rand that we are using in function flip. So providing seed, seeding the random number generation. So let me just say seeding the random number generation, All right, so here we are. Now we have this seeding. We have seeded the random number generation, and I have this. All right. So now to a very large extent, I can be very much hopeful that the number generator is going to be much more random than when I have not seeded it with the time function. All right, so we know that our function flip is going to return either 0 or 1. So we need to be able to get hold of this, create a counter that will be responsible for counting the number of heads or the number of tails that are being returned by function flip. All right, so I can just come up here. I can create my tails, say tails counter equals to 0. Also I can have another something here, heads counter equals to 0. Right, so now I can invoke function flip. Now function flip is going to return a value to me. Okay, so let me just say a value, since we know that function flip is going to return an integer, which is either going to be 0 or 1. All right, so now I can now check to see whether that number that has been returned by function flip is 0 or 1. So I can make use of if single selection structure now to check if value is 0. If value is 0, then I can now all right, let me check up. We say text I return 0 for tails and 1 for head. So if it is 0, then I can increment the tails counter. So I can just say tails counter. I can increment it. Increment the tails counter. Increment the tails counter. Increment the tails counter. Increment the tails counter, and then else we know that the other number, if it is not 0, then it is definitely going to be 1. Then I can just say else, and if, let me make a comment. It's good to always comment our code. So and if, and then we have this else head counter. So heads counter, I'm going to increment the heads counter. Okay, sorry, it was it. I'm going to increment the heads counter. All right, so increment the heads counter. Let me comment this one as well. Increment the heads counter. Increment the heads counter. All right, so and then this is and else. Then this is N4. So we are this is guaranteed that this loop is going to run 100 times. So after running for 100 times and calling this function flip to generate to simulate coin tossing, that generate either 1 or 0. We know the 0 for tails and 1 for head. So we want to know the number of heads and number of tails that has been has been gotten from the tossing of this coin, from the simulation of the coin tossing for the 100 times. So now let me make use of printf to print it out for us to see. So I can say after 100 choice of a coin, we have obtained heads. So we can this conversion specifier to represent the number of heads dash heads and tails. After 100 tails of a coin, we have obtained dash heads and dash tails. Okay, so I can just come here and then for the first conversion specifier d percentage sign d decimal integer, we replace it with the heads counter. So we have heads counter, comma tails counter. Okay, so you have this. All right, so okay, let me break this one from this point here. All right. Okay, let's see. Let's leave it as it is. After 100 tests of a coin, we have obtained dash heads and dash tails, and we have used the head counter and tails counter variable to replace this conversion specifier. All right. So all right, so now let's compile this program or run it, and if there's any error, fix the error, and if there's not any error, let's see how our output is going to be. So I'm going to go to the terminal. I'm going to navigate where I have this particular file, documents, cd document, programming, clear the terminal, cdc programs, lecture. All right, so here we are. Let me create the font size, clear the screen. So okay, so let me minimize this and then go back. So making use of my GCC compiler and coin tossing, and then output it as coin tossing. All right, so we have yes, so undeclared variables. So we have undeclared variables. All right, so let's go and fix that particular error. We didn't declare the variables head and tails, so we just initialize them. So we have int tails counter, int, and then here value, int value. So let me just declare it here, int value, and then I can just use it straight ahead. All right, so let me go back and compile the program. Okay, so we have after 100. All right, yeah, another printf 48, line number 48. Line number 48. It has more than the required number of arguments. Line number 48. So let me do away with this. All right. So let me go back again here. Clear the terminal. So I can coin tossing. After 100 tests of a coin, we have obtained 48 heads and 52 tails. So we have created a program that realistically simulate the tossing of a program using function run that generate random numbers, and we make sure that random numbers is either 1 or 2 using our modulo 2. So thank you for watching this video.